All right, most people are done there. We're gonna get rolling on to lesson 7, part 3 of using quadratics to describe situations. I think we should have most of those mastered at this point, what those things mean, how to even tell if it's a quadratic at a quick glance. This one just says what doesn't belong. Again, normally when you have these, you can argue for any of them. So wondering, which one do you think? Which one doesn't belong? And let's hear some reasoning. Okay, why C?
Because it's the only one that's dotted.
Only one that's dotted. You remember what else it's called if it's dotted? It's got a special name. Discrete graph. It's the only one that's discrete. Okay, anybody else? Something other than C. A is the only one that is a horizontal line. Perfect. Any arguments for B or D? What's that? B is the only one that's linear. I guess you could say that A is linear as well. It's the only one that has a slope that's linear because the slope is 0 for A. D, kind of hard to tell if that's exponential or quadratic. Okay, but it is the only one that goes through a number other than 2 in the y-axis. So if you're going to choose D, that's probably the way I would look at it. All right, let's move along. Question number 2. Jackson, why don't you read that for us?
A company that sells and uses online is deciding how much to charge customers to download a new movie. Based on data from previous sales, the company predicts that if they charge X dollars for each download, then the number of downloads in thousands is 18 minus X.
Complete the table to show the predicted number of downloads at each price, and find how much the revenue is. Okay, so the number of downloads, it says to use this equation. Remember, it is in thousands, so that does mean 15,000. So they just took 18 minus X. This is our X. And to get the total revenue, you take the price times the number of downloads. So 3 times 15 is how we got 45. So let's do one more row together, and then I'll have you complete it. If the price is $5 per download, how many thousands of downloads do they get? 18 minus 5 is 13. The revenue then is 5 times 13. It'd be $65,000. Okay, go ahead and see if you can complete the rest of that table. Following the same pattern, please. All right, so the one I'm most curious on is the bottom row to see if you got the equations there. Going straight down, you should have 8, 6, 3, and 0. Then the equation for this one we of course already know. Revenue, 80, 72, 45, and no revenue. Now what is my equation there?
Something is 18 minus x.
Yeah, I'm multiplying these rows, right? So my equation would just be these two things multiplied together.
I don't think you can understand.
Number 2 says, is it a quadratic? That means, does it have an x squared? Well, this does not, but let's review distributing. X times 18 is of course 18x. X times x is x squared. So is it a quadratic?
Wouldn't that be 2x?
No, x times x is not 2x. X times x is x squared. X times 2 is 2x. So yes, it is a quadratic. Why? Because of that guy right there. Anytime you see an x squared in it, it is a quadratic, automatically. Okay, let's plot them. Price per thousand. So first one was 3. Revenue was 45. Somewhere in that area. Revenue of 5. Or sorry, price was 5, revenue was 65. 10 goes to 80. 12 goes to 72. 12 would be here, my bad. 15 would be at 45. 18 would be at 0. So let's just put in the dots from our chart. What price would you recommend the company charge? Now it's kind of hard to tell. Do you think this is a peak? Or do you think it's starting to come down already? So it's kind of your discretion. I think the peak is a little bit to the left of that. So $9 to $10 might be a good range. Certainly between 5 and 10. I'll say between $9 and $10. I think somewhere in here is going to be our peak.
Wait, you want revenue?
Yeah, that is how much money you're making.
Oh.
Okay, we're going to skip the are you ready? And get right into the next few questions. Kind of all asking the same thing. There are 4 of them, I think, or is there 3? 4 of them. So we got to know what these terms mean. It says here are 4 sets of descriptions and equations that represent some quadratics that we've already seen. The graphs show what your Desmos would look like. So for each one, describe a domain that would be appropriate. Think about any upper or lower limits, the top or bottom of your graph. And do all numbers make sense based on what you are graphing? Okay, so each one we're going to find a domain. Remember, that's your x's. What x's will work? Then it says identify or estimate the vertex. So hopefully we know what the vertex is after yesterday. And what does it mean in this problem? And then identify or estimate the zeros and what does it mean in this problem. So we're going to do all of those for this one. So question number 1 says identify the area of a rectangle with its length. Okay, so it has a perimeter of 25. Graphing the area up and down. Side length is the x's. So domain. If it has a perimeter of 25, what do you think the range of our domain is for length of a rectangle? What's the smallest it could be? What's the largest it could be?
0.
Yeah, probably not including 0, but it could be between 0 and 25. Because if the side length is 0 or 25, I mean, it could be 24.99. It would be a funny looking rectangle, but it is possible. Vertex.
38, 39.
38, 39,
And 30.
okay, it appears close to 40. So 39, 38. So about 30 or 39 square meters. Largest area. Possible. Now, I'm not quite sure the graph is appropriate here, depending on what you're graphing. But to me, what would be the highest area that you could get if you have a perimeter of 25? Okay, but the perimeter is 25, right? So 12.5 won't work.
156.
So what's 25 divided by 4? 6.25. So we could figure it out exact. So I guess that is pretty accurate. I thought they had it slid to the right a little bit. But 6.25 would be the largest side possible. Now the zeros. It appears I have 2 zeros. One is right there. That means if the length is 0, the area is 0. And this one is saying the same thing. If the length is 12.5, the area would be 0 as well, because the other side would have to be 0. So those are the lengths when the area is not possible, 0. Question number 2. Again, look at what you're graphing there. Do this one together, and then I'm going to have you try 3. Number of squares as a function of the number of steps. What is the domain? So this would be steps. This would be how many squares you have. So what am I concerned with the domain with my x's? Okay, am I going to have negative steps? When we've done these patterns, have you ever seen negative numbers? No. So I'm going to exclude the negatives. And I'm going to have to say the number of steps has to be positive. I'm only going to be concerned with this half of my graph. The vertex would be that point right there. And maybe you can see this. If x is 0, in this case n, if n is 0, how tall is that going to be? Well, what's 0 squared plus 4? It's 4. So that means step 0, 4 squares. Now what are my zeros here? What is across the x-axis? Never. So there are no steps. That will be 0 squares. It never crosses my x-axis. Okay, why don't you try number 3? All right. The domain. So what x values do you think would make the most sense here? Notice you are graphing time. Suggestions? What's that? Yeah, I would say no negatives again. If you're dropping an object, I don't really care what happened before you dropped it. So time has to be positive. Vertex. Again, we can double check to be sure we're right here, but if time is 0, what height am I at? 0. Vertex is 0, 0. Makes sense, distance fallen after 0 seconds would be 0, because you haven't dropped it yet. And the zeros. There's only one. So the only time it's going to fall 0 feet is before you drop it. Once you drop that object, it will never fall 0 feet again. Question number 4. Let me try that one. I'll give you another 30 seconds or so. Yeah, I don't care about that one.
What's your motion? There's a zero, so it has to be like both X and Y zero.
No. As long as you list it as a 0. It's where the height is 0, so the y is 0. You don't have to list it as a point, though. All right, so the domain on the first one. A lot of people said positive. That's fine. And actually, I could zoom in. I'm only concerned with a certain section of the positives, even. I'm going to say between 0 and 6. Because I don't really care after it hits the ground what happens. It's just going to sit there. But for sure, positives, no negatives. Vertex. All right, so if I plug in 0 for the x, 0 right here. 0 squared times 16 is, of course, 0. What's my height? 576. That is my maximum height, my starting height before I drop this thing. It's the exact opposite of number 3. 3 wanted the distance dropped. This is height of an object after it's being dropped, height from the ground. Zeros. Not too concerned with this guy. That's -6, that's negative time. So this is the one I'm only concerned about. What does that mean? What's that? And what is it? 6 is my 0. Could list it as 60 if you wish. 6 seconds for that object to hit ground. Okay, taking a look at your homework then today, starting on page 64. There are 7 questions today. 5 does ask you to use technology, use Desmos, answer the questions accordingly. Using Desmos, though, we probably don't have to estimate anything. You should be able to get exact just by clicking on the graph. Question number 7, I do want to make note of that one. It is a select all problem, but they are all on the next page. So unfortunately, you do got to flip back and forth to see your choices for number 7. So 1 through 7 for tomorrow.